Okay, guys, I'm gonna do one question with you today to practice how to sketch a function. So let's suppose that this function is given to you, y equals to minus x to the power of 3 plus 7x plus 1, okay? And you're gonna sketch this function on a piece of paper, which is given to you, obviously, in your exam, and you're gonna do it within this domain from minus 3 to 3. Sometimes they give you also the range if they wanna do you a favor. But let's suppose that range is not given to you. You only have the domain of your function. Okay. So what is the goal? We have the Cartesian plane on a piece of paper. Okay. And we're going to sketch this function within this domain from 1 minus 3 to 3. Okay. How can I do it? The very first step. So what is the goal? Sketch this function. Okay, what is the goal? So first of all, I'm going to go and take my calculator. So document, file, new document, and now you have to choose. You're going to go for add graphs. Add graphs, okay? What is your function? Minus x to the power of 3 plus 7x plus 1. So now you have the graph of the function, okay? But the thing is that I don't see the whole part of the function. So I need to zoom out. So I'm gonna go in menu and I'm gonna choose zoom out. Press one time and here we go. You have your function. Now, what I'm gonna tell you right now is optional, but it's gonna really help you to graph your function better, okay? And be more basically sure about your final answer. You're gonna click on your equation and here you're gonna put the domain. So we're gonna get rid of the part of the function that we're not interested in to see. How? You're gonna choose control equal. You're gonna go for this vertical line and now you're gonna put the domain. What is the domain? All the x values within this range. One more time. You're gonna do control equal and you're going to put this sign here. You're going to put x here. We're going to put minus 3 and here you're going to put pardon me, here you're going to put minus 3 and here you're going to put plus 3. Okay, if you press enter right now, you're going to get rid of the part of the function that you're not interested in to have. Okay, now how can I sketch this function right now? How can I sketch it? Okay, first I need to go and find my boundaries values. Okay, so let's go and find them. How? Analyze graph. I'm going to go and choose minimum y. Look, if I choose this range on my calculator, it's going to give me the minimum point, which is 3 and minus 5. So this point is 3 and minus 5. What about the other case? One more time. Menu, analyze graph. You're going to go for maximum this time because this point, the extreme point on your calculator, the boundary point is the maximum point within this range. Okay, so minus 3 and 7. So remember, for the left side I did a maximum point, for the right side I did a minimum point. It depends upon the graph of your function. Okay, these 2 points are very necessary to have. What is the next point? The next point is to find the local minimum. So I'm going to go and choose minimum, and within this range I can find the local minimum. This is the these are the coordinates of that point. And can I go and find the maximum point, maximum local? Here is the local maximum point of your graph. Okay, so you have these 4 important points. Are we done? Not yet. We need to find also the x-intercept. So what are the x-intercepts? One more time. Analyze graph. This time you're going to choose 0. Remember, for every x-intercept you have to do 1 time this process. Okay, so this is one x-intercept. One more time. Analyze graph. One more time. This is the second x-intercept. And what about the third one? So one more time. This is the third x-intercept. Okay, these are all the critical points that we need to show on the graph. And also we need to find the y-intercept, which is very easy. I'm going to tell you how to do it algebraically. Okay, now I'm going to go and draw this function based on the coordinates of the points that I have. First, minus 3 and 7 and 3 and 5, minus 5. So minus 3 and 7. So let's say that this is 1, 2, 3, 4, 5, 6, and 7. Maybe 7 is here. So this is the first point, minus 3 and 7. What is the second point? 2, 3, 4, and 5. 3 and minus 5. Okay, let me change the color. Let me choose the white color. Okay, so these are the first 2 points. Now, what is the other point? The other point is let's show the x-intercepts. Minus 2.57. Minus 2.57 is here. So more or less it's here. This is the first x-intercept. Minus 0.143. It's very close to the 0 point, so it's here. And what is the third point? The third point is, the third x-intercept is 2.71. 2.71 is almost here. Okay, so 2.71 and 0. This point was minus 2.57 and 0, minus 2.57 and 0. This point, I think it was minus 0.143 and 0. These are the x-intercepts. Let me check. 143, yes. So what is your minimum and maximum local point? 153.813. 153.813 is going to be, it's going to be a little higher than my graph. Let me see if I have enough spot to graph it. Yes, we are lucky that we have a little spot here to graph it. So it's almost here. What is that? 153 and, is it 53? 153 and 813, yes. Okay, and what is the local minimum point? Minus 153 and minus 613. 3, 4, 5, 6 is here. Minus 1.53 and minus 6.13. Okay, so these are the points. Now we're going to go for sketching the function. These are the points that okay, what about the y-intercept? How can I find the y-intercept? For finding y-intercept, all you need to do is to put 0 instead of x. This is 0, this is 0, so y-intercept is actually 1. Okay, 0 and 1. Now all you need to do is to connect these points and try to keep it like a curve. Okay, so don't go for a straight line, please. It's a curve. Here we go. You have sketched your function on a piece of paper. Normally the paper that they give you in your exam is going to be definitely more precise with let's say beautiful clear grids. Okay, so there is no way to make a mistake. You can almost be very precise. Thank you so much for watching this video, and I hope it helped you to answer this part of your questions if there is any sketching part. Thank you.